Hi everyone, are you able to hear me clearly? Hi Ravi, hi Elvin, hi April, George, Krishna, Manu, Narendra, Nitesh, Ravi, Sahasra, Sahida, Shamit, Hang, Pradeep, Rahila, Sunesh, RS, Tegu, Sunny, and Vikas. All right, today's session is going to be very exciting, and we are going to skip ahead to Scala today. All right. I'm not sure if Mohit is around. I think he was interested in. Okay. Yeah. So, Sunny, what I thought about is that we have created a very good hands-on videos with Scoop, Flume, and Uzi, these three topics, and I'll share it today with you. Okay. And next Saturday, uh, we would we would sit in the class, and then if you have any questions on those three topics, we can take those three topics at that time. Okay, because these three topics are very hands-on, so you would need your own time to follow follow the videos, and then do the same thing on lab. That's why I thought about sharing Scoop, Flume, and Uzi's pre-well recorded videos. Okay, the way we have recorded W video, in the same way we have recorded Scoop, Flume, and Uzi. So we will discuss your questions related to these three topics. I hope that will be okay with you. If it's not okay, we can take a class. That's not a problem. Okay. So the model that I'm suggesting for Scoop, Flume, and Uzi, right? So these three topics are very small. Okay, one hands-on on each is sufficient for learning that. Okay, so these are hardly around 10 minutes each, hardly 10 minutes. I think maybe lower than 10 minutes actually. So these are 10 minutes each video for Scoop, Flume, and Uzi that I'll share with you. And then, and then, and then when we meet next time, you can ask questions if you get stuck anywhere. Okay. Sastra's suggestion is give an overview in a class. It'll be useful while going through the class. Okay. All right. All right. So there are quite a few questions. Let me just go through these questions and then all right. So instead of jumping back into class, let me first try to answer your questions. Okay, there are quite a few questions. All right, let me save it. All right, so this is one of the questions, and I'll save this as 18th February. And okay, there was a folder with the name Big Data Trainings. This one, my classes, class notes. All right, and today is 18th Feb, 18th Feb 17.txt. All right, so first question is from Ravi. I'm concerned about my progress in learning big data and Hadoop, particularly regarding project. I did not even get started on it. I tried a little bit, but could not figure out where to even start. I could not see the topic list that you announced for the project. Not sure where to find it. I'm getting nervous about not being able to follow it. Okay, so no worries, Ravi. No worries, Ravi. What I can do is let's have a one-on-one session. And if there is anybody else in the class who feels that they are kind of lost in midway, okay, feel free to schedule a one-on-one. Also, I will basically maybe, okay, um, give a walkthrough of what is where in LMS. Okay, so regarding the project, I think this we can reiterate today. So there are two questions here. One, uh, I'm kind of lost in the course. That is one common question which some of us have. And second is that I don't know what project to follow, right? So I will quickly, so I have three solutions for it. One, I'll just give you a walkthrough right away. Okay, walkthrough of project. And second, let's schedule a one-on-one. And third, I'll via email, I will send you the walkthrough of LMS. Okay, so these three things would be sufficient, I hope. Okay, all right, sorry, I had paused the screen. Okay, and it forgot to unpause it. Okay, all right. So a project walkthrough was very, simple. So let me just open my courses. No big data, and if you click on my courses, you will reach here. Okay, so this is the course. This is the course. Let it finish loading. Okay, because there are so many YouTube videos, that's why it takes a little time to load. Okay, so in the session number 9, I think, yes. Here is the sentiment analysis project. Okay, this is the project about sentiment analysis. Second was Hive subjective assignment. That was second assignment. Okay, so once you finish these two assignments, that should be sufficient for you. Okay, I could see that you have some of you have actually finished the Hive subjective assignment. So one was this, where we are trying to do a very simple querying over this table. Okay, we are trying to first create a table from a what do you say, tab separated file, and then we are trying to create queries for. So this is the background on the this particular assignment, and then you can answer these two questions. Okay, this was the assignment for the project. Sorry, this was the assignment for Hive. Okay, now let's talk about this sentiment analysis project. Okay, so here we have already given an entire walkthrough. We have already given an entire walkthrough. Okay, whereby we have provided that this is our data set. Second, this is the query that you can use, and you can, once you are done with the query execution step by step, then this particular table will be created, and then we will present this table using Hortonworks driver. Okay, Tamika's question is, for our projects, do we need to focus on partitions and maps, or it doesn't matter? Okay, so you will realize that for getting the basic thing up, the map reduce, all of the things, may not matter much. But when you optimize, when you try to improve the performance in the real life scenarios, you will have to think about what goes underneath. Okay, that time, that knowledge will come into play. All right. So you don't have to focus on, any technology aspect. Let's focus on getting it executed end to end. So this project basically tries to plot the overall sentiment of a movie called Iron Man. You can, and there are many variations possible. I've suggested these variations here. Okay. So, this is the problem statement, and then these are the steps. Okay, these are the steps on how to create data, and once you're done with creating data, from step 5 onwards, you have to present it. You can change the mechanism after step 5. You can present this data using Tableau. I have sent you a video showing how to use Tableau with Hive. Okay, so either you can present data using Tableau, or you can present data using Microsoft Excel. We found that installation of these add-on inside Microsoft Excel were very much buggy. Therefore, we decided to move on with Tableau. So I would suggest you Tableau instead of this part. I hope this is okay with you. Okay, another good question from Tamika is, when we upload our solutions, do we need to load the results and query? You just have to first give us the query. Second, a screenshot of your results. If you are, let's say, creating Excel sheet, then send us the Excel sheet for presentation of the data. So, and also point us to your table that will get created in Hive. Okay. That should be sufficient. Ravi, did I make sense to you? Okay. So, okay, let me repeat. Is my voice breaking by any chance? Okay. All right. Audio is fine. Good. Let me repeat. So the project is sentiment analysis. What does it mean by sentiment analysis? And sentiment analysis means understanding the behavior of people over time, whether positive or negative, towards your brand. Okay, towards your brand. Here, the sentiment that we want to gather is Iron Man. And how are we going to gather it? It's very simple, actually. What we're going to do is we're going to download some data from Twitter. We have already downloaded it, put it in this folder. And once we are done downloading it, then we create Hive table around that data. Okay, so now we have a table representing tweets from across the globe. Then we create a dictionary. This dictionary also we have provided to you. This dictionary contains the words and their sentiments. Okay, this dictionary contains both the things. Okay, the word and their sentiment, whether it's negative or positive. For example, bad is negative, good is positive, nice is positive, and not so nice would be negative, right? So what we do is in this exercise, once we have loaded tweets in one table and dictionaries another, now we have to find out the sentiment of each tweet. And how do we do that? We have to break down each tweet into words, right? We have to break down each tweet into words, and then once we are done with breaking it down into words, then we join with another table. We join these tweets with another table called dictionary. from where we pick up the sentiment for each word, and then we group it by. So first we break it down one word per record, and then we again group it to count the overall summation. Okay, so from each word in a sentence, let's say our sentence is, our tweet is, this was good. Okay, so for this we would find out that it is 0, 0, and this is positive. Okay, and had this been saying this was not good, right? So the sentiment of this would be 0, and was would be 0 again. This is negative, and this is positive, right? So the end result here is is 0, okay? And this end result is positive, okay? After summing up all the values for each. So we group by the tweet ID and sum up the sentiments. Right. And once we are done with that, you could come up with your own creative ways. For example, you decide that instead of summing up these two, I will multiply. I'll multiply. Okay. And that should also make sense, but what would happen to these kind of scenarios? Okay. Then you have to say neutral means 1 and negative means -2 and positive means +2. So here it'll be 0. Now, in these cases, what we're going to do is, if the overall sentiment is positive, we are going to say positive. Otherwise, we are going to say negative. Okay. So this is going to be positive, and this is going to be negative. All right. So this is what we're going to do. If you take a look at the query here, this particular query. So you see, we first create this table from, and location is this one, which means we are loading that data, and then we load a dictionary. But before that, we are going to copy this file. Okay. So what we are trying to do is, we are going to break down each tweet per word, then find out by joining, we find out the sentiment of each word, and then group it back per tweet and sum up the tweet, sum up the the sentiment. Okay, so you can see that here we are doing left outer join on dictionary, and then we are saying group by. You see, group by ID, and then we are summing up polarity. Okay, so here, though this is bad, might result in neutral, as you can see. Okay, so this is our SQL query. Okay, does it make sense to you, Rabi? Just go through these both queries, and query as well as the document. Okay, all right. And if you get any questions, please feel free to have a one-on-one schedule with me. Just that when you're scheduling a one-on-one, please send me 2 or 3 time slots. 2 or 3 time slots. Okay. All right. So there were a couple of more questions. All right. Okay, looks like as per Alvin, There's a storm in California. Okay, so we wish you staying dry. Uh, all right. All right. Wonderful. Okay. There were, yeah, I was trying to find those questions. Here we go. Okay. There are two questions from, okay, good. So the two questions from Elvin are, number one, I know you can save any queries that are developed. Can other users use your saved queries to run on their own? So actually, Hue provides something called a workspace, and then those can be shared. Okay, but not without your choice. Hue has this feature called workspaces with which you can do that. Otherwise, what you can do, in case you really want to share your work with your colleague, save it in a common folder, or let's say /tmp folder, or put it in HDFS folder somewhere and give your folder public permissions. It's up to you to give public permissions, and so that others can read your. Okay. A clever way would be to put your queries or any work that you want to share with your friends in the HDFS your home folder and share that folder. If you want a centralized folder to be shared with your other friends, what we can do is we can create a folder at the top level, like /data or something, on which we can give permission to you to write, and then others can see it. All right, that can also be done. Okay, because I would not trust Hue kind of model to save and share my work. I'll prefer that to be shared with HDFS. The the second question is, can all see my developed Hive query? Can all my developed Hive query be organized in folders and subfolders for easy reference later? Yes, you can put that in HDFS and then you can use those. All right. And whenever you want to use them, copy to local and run them. Also, as you will see if you are running Oozie, then you inevitably have to save your work in HDFS. Okay. There were two questions from Sunesh. A question from Sunesh was, I used the following command in Hive to get the outputs in local folders, and I'm not able to find it anywhere. Okay, insert overwrite local directory this, select star from u_data. Insert overwrite local directory this, okay, yes. So this is a very interesting point. So I'm guessing that you are using the Hive from Hue, right? From inside of a Hive, you're using Hue. Sorry, Hive. You're using from command line? Okay, then it should happen fine. All right, let me again take a look. Yes, it should actually work fine. Okay, so, all right, let me just make a note of it. The other thing could be that whatever folder you're trying to make in /tmp, so all of you, /tmp in Unix generally means a folder where temporary data is stored. And this temporary data is deleted by the system when you reboot. And so here we are trying to create a folder inside TMP by selecting data from a table in database. Okay, so this is something I can take a look at. in your home directory, and then I think I should be able to find it. Okay, so let me take it offline. I think it would require a little bit digging. Okay, all right. And this is by Sunish. Okay. Okay. So you cannot check TMP using Hive. You have to come out of Hive and then check. All right. Good. Great. Did I miss anybody else's questions? Second question. Okay. If I use overwrite one time, no screen output will be seen afterwards for any command until I delete the table. Okay. If I use overwrite one time, interesting, interesting. This is something I'll take a look into, because overwrite means that you are going to overwrite this particular file. Okay. So maybe the results from select star from udata are empty, and therefore this local directory is getting empty records. I'll have to take a look at it. All right. Okay, so let me take it to the top of the file so that I can. Okay, so that's about the questions. Now, quick questions to all of you. How many of us have gone through the Linux assessments? This one? Nobody? Okay. 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 So Tamika, it'll be great if you take a look at it. I would love to have a feedback from you. Okay. So, s- all right. So those who are comfortable or not so comfortable with Linux, please evaluate this assessment. So I have built it for everyone. So with your feedback, I could improve it and could make it better. All right. Okay, because this is something public and people use it. And this is something first time we are trying to do it. We are trying to, here we have tried to build for the first time an auto assessment system, automated assessment system, whereby it will evaluate the work automatically on our cloud. So those kind of assessments we have tried to build here. Okay, this is something novel in the domain of learning that we are trying to do. Okay. Okay, so we our aim is, okay, our aim is to take a look at how we learn using assessments. Okay, a question from Sunesh. I do not have the option of quiz start in session 9. Interesting, interesting. So when I click on this one or subjective, which one are we talking about? You don't get this one. I see. I see. Thank you, Tamika. Probably it is the browser issues. I'll have to take a look at it. Probably it is browser issues. All right. Okay, so I can give you, you know, or you can simply, what you can simply do is you can just go to these links which I'm providing you. Yes, are you able to see the link? And similarly for others, let's say Hive quiz, and in the similar way, okay, it should work. Okay, let me know in case you get stuck. Good, good. Thank you for bringing it to my notice. Feel free to drop me an email at support@cloudxlab. I mean, both the email IDs are same, support@no big data. Okay, so yes. So feel free to drop email to either of them. That should be fine. Okay, good, good, great set of questions. Thank you for bringing it to my notice. All right. All right. All right. So today we are going to discuss something called Bloom filter. Okay. So far in HBase, we have discussed that HBase is used to store humongous data in tabular form, where the value in any of the cell can be edited at any point. So the places where you have to modify a tabular data, you have to modify the data rapidly and is tabular format, and the data is going to be humongous, as in it is going to have billions of rows and billions of columns, then you use HBase. Okay, and how does HBase manages to do so? So HBase basically have HBase master and region servers, and table is broken into regions, and regions, as they keep on becoming bigger, they automatically split and keep on moving between various region servers. An HBase master is like a big index keeping track of which region is on which machine. Okay, so that's all. That's how HBase manages such humongous data. And actually, all of the files in HBase are stored in HDFS. So since HBase converts the tables into underlying data files, and these files are stored in HDFS, just like Microsoft SQL stores the data files of each table in the file system. In the same way, HBase stores the data files in HDFS. Okay, so this is what we were discussing. So there is one feature of HBase called Bloom filter. Okay, that's what we want to discuss. And as we have discussed that HBase might have too many IDs because there are too many records. Let's say there's a table which has billions of records, and which means since every record is having its own ID, therefore there might be a billion records. Okay, so when you have billions of records, the traditional indexing may not suffice. Traditional indexing is generally based on a binary search tree, and that may not be sufficient because those kind of trees are little slow. For searching in those traditional indexes is hard. Okay, so that's where a data structure or an you can say it's a statistical data structure. That's where data structure like Bloom filter comes into play. So Bloom filter is like index, okay? Is like index on the table. So how does Bloom filter help and how does it work? So here the Bloom filter is nothing but a of smaller list of records. Imagine, imagine there was, okay, imagine there was a single machine. Let me take a better analogy. Let's say there is a building, okay, and this building has a watchman or a receptionist, whoever receives the, answers to the user's query. So there is this building where there is a receptionist, and this receptionist answers to all people's query. People come to the receptionist and get their queries answered, right? So so this receptionist is overwhelmed by all kinds of queries that are coming to it. Okay, so there are thousands and thousands of people coming to receptionist, and even though receptionist has kept a huge list of people who are allowed, still that list is really really humongous. Imagine that list to be of say 100 pages, okay, or say 500 pages. Okay, so the list is made up of 500 pages, and when people come and say that am I allowed, so receptionist looks into this index, and this index is sorted by the first name. Still it takes a long time for the receptionist to look into this list and answer. Okay, so for example, on the right hand side, okay, on the right hand side you have this receptionist. People came to it. There are 1 billion names with it, and it looks into the list and then answers. Okay. Now, it takes a long time for it to look for records even in 1 billion data, 1 billion records, because these records will be in the disk and therefore it'll take a lot of time to read from the disk, and hence it's hard for it to answer quickly. Okay. Now, even if this data is sorted and we are having these traditional data structures like B tree, binary search tree, and all that, still it's going to be very slow. Now, what we do in such cases is we put another receptionist called Bloom filter. Okay, so the first checking is done by Bloom filter, and in Bloom filter, instead of giving the full name, let us say we just give the Bloom filter only first two characters of each name. Okay, this technique is generally called hashing, and we don't generally pick up only first two characters. Instead, we compute a number against every name called hash code, and we give that hash code instead. But for this example's sake, let's say we keep only the first two letters of every name that is allowed. Okay, so a Bloom filter keeps a smaller list, right? How many names can be there with with two digit two characters? Yes. How many maximum names could be there if you how many maximum records could be there if there are just two letters? How many names can be made out of just two letters? Yes, maximum. So Ravi, we can repeat. We can repeat the same character. Okay. 2C2 is in the scenario we cannot repeat. Although your answer is correct in the cases where we cannot repeat the question for this. Yes. So my question is, out of two characters, how many total permutations? When I say two characters as in, okay, so I think I'm basically saying the same thing again. Let me rephrase it. Let me rephrase it. How many total words of length 2 are possible? This is better? So we can have AA, AB, AC, and so on up to AZ, and then we can have BA, BB, BC up to BZ, right? And similarly, we could have up to ZZ. Correct. So we will have only 26 into 26, which is 576, right? If I've not forgotten. Okay, I think it's 576. 25 into 25 is 525. No, this will be more than that. It'll be 6 something, 676. Right. Thank you, Mahmood. Okay, so yeah. So Ravi is saying that it'll be 26 into 25. That is true if we are not allowed to repeat the letter. Here we are allowed to repeat. 26p2 is 26 into 25. Right. Krishna says it should be 52 into 52. Not really. We are just talking about lowercase. We're just talking about lowercase. Okay. All right. So where did my, okay, here we go. All right. So this is what Bloom filter does. So Bloom filter will only carry these 676 names. Okay, just first two letters of each name. At most 676, it'll be far smaller than 676. Okay, so when a person comes to the Bloom filter, they will give only first two characters, and the Bloom filter will quickly check if those two characters are in the allowed list or in the blacklist. Okay, and then it will be Bloom filter who can confidently reject. Okay, it's a very important thing to understand. Bloom filter can confidently reject people, right? But it cannot confidently allow, because, for example, Midli, Biswa, Mahesh, Mamta, Abhay, right? MY, BI, MA, and AB. While AB matches with Abhinav, but Abhinav is not allowed in reality here. Okay? This AB is not really allowed. Therefore, when Bloom filter finds a match, it sends it for the checkup in the actual database. So apparently you will see that there are two calls, but in reality, it leads to a very high optimization. Okay, so Bloom filter maintains this list. It is generally called Bloom. It's called Bloom vector. And then it basically keeps it in the memory. And when somebody comes, it will basically quickly reject a lot of invalid traffic. Okay, making the life of this search, the existing search, very easy. Okay, did it make sense to you? All right. Though we do these kind of things quite often in real life, right? But when it comes to computing data structure, somehow we start feeling that it's too complicated. Okay. So if you see here, this is our Bloom filter. A user comes in and says that, hey, do you have key one? Filter might say that, no, I don't have. So at this point, if it says no, it's saying confidently no, there is no further checking required. But if it says yes, if the filter says yes, okay, then the actual checking would happen, and there could be yes or there could be a no. In case of no, you might feel that it was an unnecessary data access. But if you consider all the traffic that it is ignoring, this particular case is rare, and therefore is less actually, and therefore this extra expense that we are getting here would be basically kind of this extra expense that we are doing here would basically be uh, compensated by this. Okay, I hope everybody is clear about Bloom filter. Alvin, April, George, Jiankun, Kar, Krishna, Manu, Mohit, Mohsin, Narendra, Nitesh, Ravi, Sudhakar, Sahida, Samit, Hang, Mahmood, Pradeep, Rahela, Sunish, Srini, RS, Tamika, Tegu, Srini, Ghosh, and Vikas. Okay. Question from Tegu is, what is the case of key 3? In case of key 3, it is, let's say filter is saying that yes, we know key 3, okay? And in reality, it doesn't exist. This is false positive. So in certain cases, like in our previous example, in case of Abhinav, we had AB, but in reality, it was Abhay, okay? So these are called false positive of our Bloom filter. In those cases, it might look that this is an unnecessary disk access. Okay, so whenever data is getting updated, the filter also needs to be updated. Although one thing you might notice that updating the filter, if you just keep on appending to the filter, it should be good enough for beginning. Okay, it should be good enough. So that's why updating a filter becomes easier. Okay, so no, Tegu. In case of HBase updates the Bloom filter or the Bloom data as and when the actual data gets updated, just like indexes. Okay, just like indexes. Great questions. So yeah, should we move on? Yes, this is kind of index on index. Yes, you are right, Ravi. So question from George is, how is false positive get handled? So false positive is, user comes to you, filter says yes, so the actual access happens, and that time it is denied. Okay, okay, so Bloom, in case of false positive, Bloom says yes, and then the actual access goes to the storage, and then storage is the one which takes the final call. Do it make sense? All right. All right, good question. Now, the questions further is from Krishna and Sudhakar. Your questions will get answered in the next slide. Saida's question is, if two names have same first two letters, which one does it pick? So Exactly, very good point, Saida. If let's say there are two, let's say filter says yes, correct? Filter says yes. Do I have an example here? Yeah, you see, Mahesh and Mamta, it is MA, right? So if a user is coming from for say Mamta, you'll first check MA, okay? And then it'll say, yes, we have in the record, but let me check with the master. Then it goes to the actual search or the storage, and then the comparison of whole Mamta against the record happens here. Okay, do it make sense? Yes. So the again that's a very important part. So again, the whole words check happen. In case Bloom filter says yes, the whole word check happens. The usual thing happens. So Bloom filter actually avoids lot of lot of unnecessary traffic. Right. Like for example, Sandeep, SA does not exist in the list. So it gets rejected from here. It does not go any further. Because if first two letters are not matching, therefore the actual search is meaningless, right? There could not be a scenario where the whole word does not match, a whole word matches while first two letters are not matching. Or could there be? Yes. Could there be a scenario where two names are matching, but their first two letters are not? That's not a scenario, right? Therefore, if based on first two letters, if something is rejected, it's definitely not in the actual list. Yes. So first Bloom filter would accept ma. Okay. And then search for Mamta starts, the actual one. Okay. So if let's say somebody is searching for Mamta and then MA has been successful and therefore, all right. Also, please note that when we pick out the two letters, it'll be the distinct values here. It won't be repeated values. So MA and MA would not repeat here. It'll be only MA. And it doesn't know about the actual word. Because why doesn't it know about the actual word? Because we need to maintain this data in the memory. We would like it to be very, very slim and thin so that we would like it to be very lean data so that we can maintain it in the top memory. And then as soon as somebody comes in, we could just check it and either reject upfront or let it go. Okay. So trimming down the traffic drastically, that is the role of Bloom filter. Ravi's point is whole word check happens in the next phase regardless of multiple people exist with the Bloom filter or only single name exists with the Bloom filter. That's correct. That's correct. Sandeep will not get accepted because there is no essay and it'll get rejected from here itself. Right, Samit? So if had Sandeep been in the actual list, if had Sandeep been in the actual list, then there will be assay in the Bloom filter, and therefore it could have got accepted. Right. So rejections would happen instantaneously at Bloom filter level, and Except when it says, yes, I found in my two letters, then the actual search would happen on the whole word. All right, good, good. So there was a point from Ravi. I'm not. Uh, I'm not sure if I read it whole. Whole word check happens in the next phase, regardless of multiple people existing in the Bloom filter, or only single name exists with Bloom filter. Correct. Okay. So Sandeep, sorry. So Samit, did I make sense to you? Or maybe I did not understand your question correctly. All right. So if that this particular word exists in the final one, and then it will work. Okay. Next question is from Sunesh. Will the two letters be in sorted order in the file? Yes. These will be in the memory, and we use something called vector. Okay. We use something called in-memory binary vector. Okay. So search on it, you will find that. I'm skipping those details. I'm just telling you here that this list is maintained in the memory in a way that we could quickly check. Imagine this to be a big array, okay? And instead of these two letters, it's just numbers, okay? And in the array, on every index of that, these are the indexes in the array, we mark it true or false, okay? That's how it's kept. Just like in hash table, we can put the key and it gives you the value. Similarly, in the array, if you put the index, it gives you the value. So these are generally the numbers, and at these numbers in an array, we maintain false or true. Okay, this is how it generally is implemented. Okay, a question from Sunesh. If 1 million names, will there be a memory overflow? Not really. Not really, because even for 1 million name or 100 billion name, no matter how many names are there, if we are just picking up first two letters or hash code, it will not go beyond an integer. Okay, that's why we choose our hashing mechanism. This is called hashing mechanism. This hashing mechanism, whether picking up first two letters or just converting into integer or converting into a very small um, 1 byte number, it's up to our logic, right? And basically that logic should be such that that generated bloom list or bloom data should be very small. Okay. Yes, Ravi, the bloom filters data is cached in the memory in a very heavily optimized manner. All right. So not all arrays are cause overflow. All right. If it is managed properly, it will not cause overflow. All right. Great. Great. So I hope I was able to explain this. This is a concept and why we are discussing Bloom filter, not because we are going to use too much in case of HBase, but because when it comes to big data or when it comes to high performance computing, Bloom filter is something as a concept required. There are tools, almost new generation tools, almost all of them, they have support from for Bloom filter. Also, there are independent tools for Bloom filters. So as a concept, it's a very important concept in computing. Okay. And as a matter of fact, in one of my Amazon's rounds, they asked me about Bloom filters. They asked me indirectly. Generally, no. Bloom filter is not chained. Okay, Bloom filter is not chained. Instead, we tweak our hash code. We tweak our hashing mechanisms such that we don't have to chain them. Statistically, chaining Bloom filters, it's like zipping the zip data. Okay, so chaining Bloom filters does not give you any additional advantage. But it's a very good question, Ravi. So yes, I too had the same doubt, like, will it be any advantageous? So I had to do a little maths, but we could statistically prove that there is no benefit of chaining Bloom filter. Instead, tweaking the hashing function is something gives you a good result. All right. I hope everybody is with me on Bloom filter. It's an important concept in the high performance computing or big data computing world. And people love to ask this question. At least people will ask you that what is Bloom filter? Okay, trust me on this. If it's a decent job and there's a decent interviewer, they would ask you. All right. From HBase perspective, Bloom filters can be enabled per column family. Okay. So you could use a class called hColumnDescriptor.set Bloom filter type. You can say none. If you are saying none, there will be no Bloom filter. You could say row, meaning row IDs, based on row IDs, hashing will be done. Row keys, hashing will be done. And then the searching on row key will become faster. But if you're saying row and column, that means searching on row as well as column family, column name is column family plus column identifier. Therefore, if you are looking in a table very frequently based on row as well as column, then you could create that Bloom filter also. Okay. Also, you can set the Bloom filter type to any of these, either none, row, and row column. Okay, your question might be that why not we have a column alone? The fact is that we don't generally look up first based on column. Okay, if you want to see exact code, you can take a look at these places. That should give you a good idea. Next is that how do I access my HBase data? So far, we have discussed only the client mode, as in when we say HBase shell, then it runs. Okay, so you can also run something called REST interface. What is REST interface? Something that you can access from the browser or the URL. Okay, so in very simple words, that is the definition of REST. So for that, you have to start the REST interface. You could basically execute this command to start REST interface at 4040 port. Okay, let me try. So I'm going to log in into my web console from web SSH. Okay, let's see if it says error or it is start. It says that the address is already in use. Okay, so I'm going to call on 4041. This time it has started, I guess. Okay, now I can access my data from the browser. Like for example here, whatever table which we had created earlier, we could access them in this manner. We could say slash my table name, and then we could say row number, and then column family, followed by column name. Okay, and here we can access the data. All right. So this way, if we have this way, we can access our data using the URL from outside world. All right. So that's a REST interface, and what we have seen so far in case of HBase, that the interface that's provided to us is in get set map way. We can get value, put value. Okay. If you want to have a proper SQL kind of interface, you could take a look at Apache Phoenix. Okay. You can take a look at Apache Phoenix that provides an SQL around your HBase. Also, you can write MapReduce around your HBase, but that's little too much involving for this class. So we will, you know, you know, in the slide you can take a look at these three pieces of code. That how do you write map and reducer on HBase? Okay. So that's pretty much about HBase we have discussed so far, and we have tried to understand why we need it, how do we create the data model, and then how do we access our data. All right, great, great. Yes, HBase is basically analogous to Oracle. Okay, HBase table is analogous to table in Oracle. All right. Okay, so as somebody has suggested that I'll just give you an overview of tools, and then I'll send you the video of each of these so that you can try them by yourself. If you get stuck, let's have maybe the discussion on the next session. All right. So there are three things which we wanted to. I will send you the video. First one is Flume. Flume runs on all the machines and then keeps on pushing data to a centralized resource such as HDFS. When do we use it? Let us say we have hundreds of web servers. All of these web servers are generating data like logs, and we want to push those to a central place. So for these kind of scenarios, what we do is we install Flume on all these machines and configure Flume to push the data to a central place. Okay, and Flume will keep on reading these folders, files, or from various locations, and then keep on sending that data to HDFS. Okay, so Flume is single directional. Okay, Flume has got agents that keep on picking data locally and keep on pushing centrally. Okay. So Flume is like message queue, very hard to tell, very hard to tell. So Flume is basically for pumping data. It cannot be like message queues. Kafka is like message queues. Flume consumes or pushes data to message queues. Yes. Yes, Sunny. All right, so that's Flume. So I'll send you a video of Flume in which we have covered the entire details and shown you the examples, and then you can take a look at the then we can discuss it next week. Okay, sounds good to you? Question from Marcin: how does it differ from Java NIO, which gives channel buffer? So Java NIO is basically a Java library, and that Java library does not have an agent specifically designed for pushing data from all across the servers to a central place. Okay. Though you'll be glad to know that Flume itself uses Java NIO, okay, internally. Okay, do I make sense to you? So the design, you should go through the design and you will like it. Okay. So if we let's have a discussion next week. All right. Next is Scoop. Okay. Scoop is far simpler tool. Scoop is far simpler tool. It's basically for import and export of data from relational databases into HDFS, Hive, and HBase, and then exporting data from HDFS, Hive, HBase to relational data. So this is our usual relational world, and this is our Hadoop big data world. And Scoop kind of fills this gap. Okay, import and export. All right. And under the hood, Scoop, whenever required, uses MapReduce. So the video we are going to send you is going to have hands-on demo. Try to do it by yourself. It has been done on CloudX Lab, so you will not have any issues in running the same video, running the same thing by yourself. Yes, Scoop generates internally MapReduce code to transfer data. Okay. So all the mappers, let's say we are importing data from relational databases. Yeah. So let's say we are pulling data from relational databases into Hadoop. So instead of one machine trying to pull the entire data, this logic of importing will run on all the mappers parallelly. So all the machines which we designate for this import, as in when we say mapper 2, we want here we can also specify how many machines that we want to involve, and those many machines will parallelly pull the data from relational database. Okay, that is Scoop. Okay, so go through the video that I'm going to send you, and then I'm going to let you know about. Okay, so the third one that I want to explain to you is Uzi. Okay, Uzi basically, when we have a typical job in a real life case scenario where you have some scripts written in Pig, some in Hive, some people have written some work in Flume, and then some data coming from Scoop, some data coming from Flume, some data being churned by Pig, some are actually Java code, and all of that. And all of these things need to run in a certain sequence. For this kind of sequencing or this kind of project execution, we use Uzi. Okay, so take a look at the example that I'm going to send you about Uzi, and then have a discussion next week. All right, everyone? Okay. Why I'm doing this? Because I believe that watching the video, you can pause it and try by yourself, and therefore you will be more confident, because all these three topics are more practical than the theory. Okay, so try completing exercises. If you get stuck, schedule a one-on-one with me. Okay, schedule a one-on-one with me by providing 3 different time slots, and then let's have a okay. Let's have a discussion. A question from Kerr is: Airflow is generally used for workflow scheduling. Airflow, I think it's used without Hadoop. Okay, so looks like yes, it is coming up for. All right. So basically, I think they're rewriting the Uzi part with the Airflow. Looks interesting. I'll take a look at it. So I have used Azkaban earlier and Uzi earlier. And okay. All right. Looks like it's a newer version of these things. I'll take a look. Thank you, Kar. But it's still incubating. It's not still Apache. All right. Good. Thank you for that. All right, so that was Flume, Scoop, and Oozy. All right, let me close these windows. All right, so we can do two things today. One, we can actually get started with Spark, okay? And then we can talk about uh, the Scala from tomorrow onwards. All right, so I'm trying to make more space for Spark, okay? All right, so let's get started with Spark. Let's get started with Spark, and this would be pretty easy. And okay, all right. So here we go. Yes, Spark streaming we are going to cover, and we are going to do hands-on exercises on Spark streaming. Okay. All right. So moving ahead. All right. As we said that we are going to work more towards hands-on. So to start Spark, we can use either of the following commands. Okay, so a quick overview of Spark. So Spark is basically a substitute of MapReduce, okay, and it runs on top of Yarn as well as other systems. Okay, we will come back to architectural overview after a while. Okay, and so you can write program on Spark either in an interactive fashion, the way we wrote program for Pig, or Hive or HBase from the console itself, step by step, right? In the same way, you can either code for Spark, or you could submit the job the way we said Hadoop jar, right? In the same way, we could submit Spark jobs, okay? And you can write code, you can talk interactively with the Spark. You can talk interactively with Spark either using PySpark, Spark Shell, okay, or Spark R or Spark SQL. PySpark means you will get a Python interface, Python programming interface, in which you will have additional Spark objects, which when you interact with those Spark object, you will be talking to Spark. Otherwise, you will be talking to Python. Okay. So the next one is Spark Shell. Spark Shell is a Scala shell, basically, with a couple of more objects there. Those objects point to Spark. Okay. So Spark Shell is nothing but a Scala shell. Scala is a programming language which provides us interactive shell, the way how should I say, the way Pig was providing interactive shell. Okay. And Spark class is just to run a Java class. It is not really executing it on the cluster. It is going to run locally. Spark submit is equivalent of Hadoop jar something. It submits your work to the cluster, and once it's done, you get back. Okay, so let me show you quickly. Okay, each one of these commands. This is PySpark. I'm logged into console and I have started PySpark. So when I say PySpark, it's actually executing it's trying to initialize and connect to Spark. And this console that you see here is nothing but Python console. Okay, what is a Python console? It is the place where you can write your program very quickly. For example, I wrote a very simple program, 2 plus 2. Okay, and here I could also define variables, and then I could also operate on variables. And then Next level, I can define a function which takes arguments and return say square of this. Okay, so this function that I've just created multiplies something by itself and returns a value. Okay, and then we can operate on this. So you can see that programming language in couple of statements. All right, using such kind of model, you can do anything. So this is just classic Python. What I've just typed you in front of you, this is just classic Python, right? And if you want to interact with Spark, we can we can say sc.text file. Okay, this way we can load data from the uh, usual place, the mr word count, and what was my text file input. Okay, so I can load data from that place. You can see it has loaded data from there. Let me just take a look at how many record, if anything is done or not. You can see that it has loaded those first lines. Yes. So, so I'm trying Python right now just so that you all get started very quickly. And okay, so here I have just done what we did in Pig, loaded the data and try to take few records from it. Okay. Now, on top of this record data, right? Data, I could execute my logic. I could say map, I could say reduce, and so on. Okay, we will keep on going more and more details into it. Let's say we want to just convert this into uppercase. Okay, so we could define a method called my upper, and we say x, and we say upper x, and we return this value. Okay, so this is our Python code. Don't get upset if you are not aware of Python. I'm just, uh, giving a very simple example. Okay, so who can help me to return? This is correct, right? In Python, x dot upper. Let me just see. Yeah, this is correct. So you can see that whatever I'm passing to this, it's getting uppercase. Now the data that we loaded earlier, we can run this function my upper on top of that data to generate, I'll say U data, uppercase data. All right, now let's take a look at that uppercase data. I'm going a little faster, but okay, so you can see that the data is uppercase. Good. Let me just put it in a file so that you all are comfortable. All right. All right. So this is how you generally interact with Spark. Okay. All right. Good. So this is our program to convert massive data to uppercase. Okay. The first line loads data into data. Second and third line defines a method called myUpper, which takes an argument and returns an argument. And then we are running this method on every record of this file by saying data.map. And then we are saying take. Okay. We could actually write the entire thing in a single line, but I'm not going to do this. Okay. All right. All right. So Sunny, take a look at your path if that is correct. Generally that error occurs when you have this. The other error is also we are executing this code in PySpark. Please note that. So this code is in Python. So we started PySpark and then did all of this. Okay. This is what we call PySpark. Okay. So I could not contain my excitement. And all right, sc.text file is equivalent of loading a text file. Sc means Spark context, and we are telling Spark to load this data. Load does not mean that it's loading into the memory. We'll talk about this later. Just like it's like equal to saying load data in pig. Okay, good. All right, so that is PySpark. In the similar way, we have, let me exit from here. In a similar way, we have Spark Shell. Okay, Spark Shell. So you can see that when you have interactive cell like this, okay, I could code without having the script at hand, and I could do it real time. Okay, and that's the advantage of interactive shell. You could quickly write the code, try it out, and then if something goes wrong, you make minor modification and then run it. So that's the advantage of interactive shell. All right. And another advantage of using Python, because Python seems to be pretty smooth. Okay. Now so this is Scala prompt. This is also like Python. You could do summations here. You could assign, declare things. Okay. And then do multiplications. You can see that. And also define methods here, classes here, and then use those methods in classes. Okay. And also if you want to interact with Spark, you could define a similar context, a similar way. Okay, so here we go. We are loading the same data here. Okay, and then we could take 10 records. See, this is Scala. All right. So under the hood, they're all calling Scala, whether Scala or Python, they're calling Spark under the hood. A question from Krishna. So Scala and Spark are both same? No. Scala is a programming language like Java, Python, C Sharp, or C. Scala is a programming language, while Spark is a framework like MapReduce. Okay? It's just that earlier when we used PySpark, we were also using Spark, and now when we are using Scala, then also we are using Scala. Scala is also calling Spark under the hood. Okay? If we are, so also please pay attention to this. Spark shell is to interact with Spark. Okay. If you want to just test something in Scala, just open Scala. Now this one is not going to connect to Spark. It is independent Scala. This is without Spark. Okay. This is without Spark. And if you just want to code in Python, then you can simply say Python, and then this is independent Python. Okay. This is independent Python. Good. All right. Thank you, Ravi. A question from Sunesh. Suppose we use Python for loading the data. Can we make queries using Scala for the same HDFS data? So if the data is in HDFS, you can use anything. But if you loaded data in data frame using Python, it'll be difficult to use the same thing, same loaded data using Scala. All right. A question from Kar. You have instructions on how to install Python and Scala. So those are standard instructions. Actually, you can download from anywhere. Although in CloudX Lab we have done all of that for you. Okay. So you can download Python from there. So Tamika's question is, does it matter it's Python 3 or Python 2? Very good question. So I would stick with Python 2. Okay, I'll stick around with Python 2 because most of the Spark we use Python 2, not 3. And personally speaking, I don't really like the Python 3 too much. In all my projects, even the entire CloudX Lab is coded in Python 2 itself. I like Python 2. Okay, I'm yet to adopt. Okay, a question from George. What is the advantage here, or are these just other option for how your code is written? Okay, so let me close this. Sorry. Okay, close something important. Okay, let me answer that question. What are the advantages here? Okay, we will talk about advantages of Scala in a minute after a while. Okay, so these are different languages, Python and Scala, these two different languages. While Python is easier to write, Scala is faster. Okay, Scala is faster even faster than Java and faster than Python. Okay, so that's the only reason why people use Scala. All right, thank you, Ravi. Yes. Okay, the other thing we'll discuss is Python, is Spark R. A question, somebody, Tamika was saying that people are using the latest version. So I'll give you a very good idea. You can actually use whichever version you want on the cluster. We'll talk about it. Okay, we'll talk about it. So I've written a blog on this here. Yes. So point from Krishna is, how do we know data loaded by Python or skill? You will know, trust me. As we go ahead, you will get the clarity on that. All right. Okay. So if you are trying any version, you can actually try any of the Sparks version, and that we have mentioned here. Okay. Now coming back to it. Okay. So we have, okay. So, all right. We were here. Okay. So we have these various applications like Spark R. You could use Spark R to write your code in R in the same way the way we were using Python. Okay. Spark SQL gives you a SQL kind of interface. So you can code in any of these languages. Okay. If you want to download your own Spark, you can do that. Okay. Also, if you have, let's say you have Hadoop installation already and you are downloading Spark for your own Hadoop, In that case, what you can do is first check the version of Hadoop by saying Hadoop version. In here, you can see that we have Hadoop version 2.4, and then go to the downloads section of Spark. There you select the Hadoop version and download. And the same URL, what you see here, you can just copy paste the URL and use wget to download on our server. And every download can be run in standalone mode. Okay, meaning you don't need Hadoop. We don't need Hadoop in order to run Spark. Spark comes with its own standalone manager as well. Okay. So a question from Ravi, what is R? R is another programming language, just like Python and Scala. Okay. All right. So yeah. So to run any kind of Spark, you can set these two variables. So Spark can run on Hadoop or any other models. So if you want to run on Hadoop, you set these two variables anywhere. You set these two variables as environment variable and then launch Spark Shell, PySpark, or this. Okay. We have also installed the other latest version, for example, 2.0.1. Okay. And those all can be run. All right. So you could simply say these two commands, and let's say you want to run the latest version, you could write this. Okay. So I'm going to show you this. So let's say these setting these two variables is kind of needed. Otherwise, Hadoop, this Spark will keep on running independently and will not talk to Hadoop. Okay. So you can see that. Also, while starting a Spark shell, if you keep on getting the bind related error, okay, like this we have got here, it says that, yeah, bind related error saying already in use. Okay, it doesn't matter because when Spark is starting, it blocks a port starting with 4040. If somebody else is using a Spark, then that port will be blocked and it will try to open on another. So after 4040, it tried opening on 4041. Okay, so that's how Spark is. So it creates this what do you call the interface uh, at a particular port that you can take a look. Because I'm logged into e.cloudxlab.com, I can say e.cloudxlab.com slash what was the port number? 4041. Okay. So this shows us the status of this particular Spark instance or Spark shell. Okay, we'll talk about these details in more. Here, I'm just trying to get you started with Spark. So Sahida's question is, what does Scala good in performance means? Enhanced memory management or I/O? I/O and memory management is kind of a function of the hardware. Here, what Scala provides you is generally the faster execution of code. Okay, the code generated out of Scala is comparatively fast. We'll talk about it in a while. All right. So this is how you get started with. A question from Sunny: can we use Jupyter notebooks? I missed this question. Yes, definitely you can use Jupyter, and here. Okay, so I've given a good example here for Jupyter. Okay, so you can, yes, run Jupyter and use CloudX Lab. Jupyter is kind of a notebook where you can write your code and your report, kind of the report get generated. All right. All right. So before we jump into the architecture, let's take a quick break and back in 10 minutes. Okay. Hi everyone, I'm back, so we can discuss. All right, so should we start? I think I'm a little late. Okay, good. Let's start. I'm 4 minutes late. All right. So okay. So Tagu's suggestion is to create a WhatsApp group or yeah. Yeah, you can have the group. You can have the group. All right. Okay. Great. Great. So far we have only discussed very basics of Spark. And in case some of you are looking for the first description of where is that introduction here? Okay, going back a couple of steps just to show you the ecosystem diagram and where does Spark sit in the ecosystem. Okay, so earlier what we had discussed, I think we have discussed this part, right? So the map reduce was this. Okay, so we solved our storage problem with HDFS, computational problem with MapReduce, but MapReduce was slower. Why? Because every result of MapReduce was saved to HDFS, and then the next MapReduce phase will read from HDFS. So this cycle was extremely slow, and that's where the problem was solved by Spark. So Spark, instead of writing to the disk, it started utilizing RAM. Okay, it started utilizing RAM, and that's what made a big difference. Okay, so the Spark architecture looks like this. So the way MapReduce was running on the top of Yarn. MapReduce was running on the top of Yarn. In the similar way, Spark runs on the top of Yarn. Okay, meaning Spark's core basically is managing the MapReduce kind of mechanism here. We code against Spark core and they get our work done. All right. So Spark has various libraries, streaming, MLlib, graph library, and so on. And we interact with this Spark using many languages. I demonstrated to you using Python and Scala. We will, as we go ahead, we will also look at these aspects. We'll also understand the internals of it. And then we will also go over these set of libraries one at a time. Okay? And this is Spark core. The way we just read data from HDFS can read data from other places as well. Okay? Okay, so is everybody with me on this? All right. So the example that I have provided to you is this, a question from Vikas. that can we give an example of a Spark shell? You can try this. What I'm typing just now, it should work fine. Okay, we will go into more details later. All right. A question from Sunny is, if we use Spark, no functionality of MapReduce in Hadoop? If we use, no, MapReduce is not used in Spark. The only functionality might be used in Spark is input formats. If you remember input formats that converted raw data into something that get processed in MapReduce, those parts are something Spark would use from MapReduce. Okay. All right. So Sunny's question is, it returns L Java lang string. I'll take a look at it later. For me, it was working here. If you see, I'll go up. Where was it? Never mind. So I'll just run it again. Spark dash shell. Spark. Don't do Spark space shell. There should not be any space between Spark and shell. It should be continuous. So you can see that here we are saying load this data, and then where did this question mark come from? Okay, yes, and then so you get the result here. You see, this is the result I'm getting. Okay, no, don't do the printf on data.take because data.take executes the Spark job. Okay, and it doesn't really, it basically just like pig when we said dump or something like that, it did the job in the same way. In the same way, data.take works. So it is basically in the similar fashion. All right, good. All right, good. So another question is, I see you define a function as a variable, and does this var or val remain in the memory until you exit? That's right, Mohsin. That's right. So this function, you remember? This function that we defined in PySpark would remain in the memory until it's done. Okay, just like in case of pig. All right. So the model that these people, the most of the new upcoming big data systems follow is similar to pig. All right. Any other questions? All right. So now, before we jump into the Spark, let's try to understand from the yarn perspective. Okay, let's try to understand the architecture of Spark. So Spark is made up of something called driver application and then actual application. When we opened our console here, when we opened this console, we launched this, the console, the interactive console where we typed our command, that was the driver. Okay, so driver is something which starts the whole Spark process. Okay, driver is something that starts the whole Spark process. And the Spark application runs on every node near to the data. Okay, all right. So let's try to understand the architecture. The heart of Spark, the core of Spark is something called resilient distributed dataset. Resilient distributed dataset is a kind of an array in Spark. Okay, when we said sc.text file and we provided the location of our file, right? When we said this here, when we said this, when we said sc.text file, we are telling Spark context that this is our folder, and this data that gets created is our is our uh, is our resilient distributed data set. Even though this variable looks like our usual variable, but this data is on many machines. Okay, so this RDD is spread across multiple machines. Okay, like you have heard about arrays, you have in programming languages something called array, right? Those entire array is in the memory, as Ravi was pointing out earlier, correct? But this RDD is spread across multiple machines. Does it make sense? So RDD is like a big list of objects. Some of the objects would be on one machine, some will be on another, and so on. Here, this RDD in the UI is located on 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 four places. Okay, all right, and then yeah, yeah, like input format in MR that you can think of this way. Each block, each part will be kind of input format, because input format contains, it gives out input split. This is one input split, another input split, another input split, and another input split. Good analogy. And under the hood, actually, it is input split. Okay, so RDD is spread on four machines. Okay, in this example, and when we process this RDD, we use Spark application. This Spark application is run on multiple machines. Here we have four nodes. On these four nodes, this RDD is spread, and parts of it is going to be processed by Spark application, and the resultant would either return some value to the driver, or it will run, it will create another RDD. So Spark application would either return value to driver application and, or it will give out the another RDD. Okay, so this is how Spark works. Okay, we will keep on taking a look at this architecture again and again, do some exercise and come back to the architecture, and when then we try to understand what exactly is going on in Spark. Okay, we'll do more exercises so that we get more comfortable with the model of Spark. Also, we will spend a little more time on SQL so that we can do the usual work using SQL rather than writing maps and reduces. Okay. So most of the exercises in the practical application generally move to Spark SQL. Okay. But understanding the entire dynamics is important if you are trying to build something uh, which is not tabular. Okay. So here we are. So question from Nitesh, how data is scattered over RDD on different machines? Good question. Okay, so if you think about RDD, RDD is basically holding pointers to data. RDD is just a mapping that which data is here, which data is here, which data is here, and which data is here. It's not really loaded into the memory. Okay, so when we say sc.text file, it makes a note of this statement. It makes a note of this statement that this is the file that has got so many blocks. Let's just map the partitions. Okay, that this has got say 500 blocks, so one block goes on this machine, and hence there are so many partitions of the RDD and so on. Okay, and this Spark application, when we execute something, Spark application runs on every node, okay? Processing the partition. This is called a partition, okay? This RDD has got partition. Partitions have records, okay? All right. So Spark runs in two modes. One is called standalone, okay? It does not need any kind of resource manager, and it basically, you can run standalone either on one machine or even on multiple machines. Okay. Sometimes you would like to install Spark on one machine just to take advantage of multiple cores of that machine. Okay. Because any program that we write in Spark is going to get executed on multiple machines anyway. The same thing can be done on multiple processors. Okay, Spark does it automatically. Okay, so the standalone does not need resource manager. It creates its own resource manager. Okay, if you do not have an existing Hadoop cluster, what you can do is install Spark on all the machine in the network, inform all the nodes, there's a standard config, and then launch all the machines parallelly, and they will discover each other, and then automatically, the way we had Yarn Resource Manager, we would not need Resource Manager here. Never mind. So the one that we use in CloudX Lab, is over the cluster. For production environments, mostly people use Spark over Yarn. Why? Because one, we anyway need Hadoop cluster for storage because Spark does not provide any kind of storage. Okay. Therefore, you inevitably need either HSpace, HDFS, or any other storage, right? Therefore, you would have generally, if you are serious about big data, you would be having Hadoop or a similar resource manager, and you can run Spark on top of those. A very good resource manager similar to Yarn is Mesos, and Mesos makes it possible to to run tasks in a very lightweight manner. Okay. All right. Now, when you are running Spark without in a standalone mode, this is what happens. You have a single machine, for example. Okay, the RDD would be loaded on the same machine. There'll be Spark application and driver application. Both will be running on the same machine. Okay, so all the three components would be on the same machine if you're running standalone on a single machine. Okay, also, if you by default if you do not provide any of the, if you say master local, Spark cell Python PySpark space dash dash master local, then it will run in standalone mode. Okay, so we can run a simple example in the local mode using this kind of syntax. Okay, and this example, what is it doing is it's computing the value of pi. Okay, it's a standard example eh, as part of the library. Okay, it's computing the value of pi. How many of you remember what was pi? Yes, anybody remember what was pi? Okay, no, that's okay, but the significance of it. How do you generally compute pi? Yes, so, okay, that's good. So one is parameter divided by diameter. Okay, and other was by computing the area, right? So if we know the area of a circle, then we can find out the value of pi, right? This example, what Spark guys has shown, it basically computes the area of circle by counting total number of dots here. Okay, counting total number of dots inside the circle, that is the area. And then from the area, they have tried to compute pi. Okay, you can take a look at this piece of code. Okay, you can take a look at this piece of code. All right. So since we know that pi r square is the area of circle, and therefore if we know the radius of circle and the area, we can compute the value of pi. Okay, so that's what they have done. And the way they have computed area is by counting dots inside the circle, and that dots, total number of dots is basically the area of circle. Okay, the other important part to understand is they have tried to break it down. They've tried to break it down into parts. Now, this is a very important point. That let's say we have to count total number of dots inside the circle. What is it that we'll do? We will basically traverse through all x and y in this box and check if a dot is if a dot is within the circle or not by using Pythagoras. So, and if it is within the circle, then we count it. Otherwise, we say that it's not. Okay. So I mean, the way they have done is they have cut down this range into parts like 1, 2, 3, 4, 5, and for each of the part they have tried to run it in a separate thread. Okay, so here using 10 parallel threads, they have tried to compute the total number of dots inside the circle. Okay, was it too much? Did I make you zone out? All right, did I confuse you? All right, so although it's not something really needed, but let me just give you a quick idea about, let me try to make it a little more useful. Okay, so let's say here is a big circle, right? And we want to find out, how many dots are inside the circle and outside the circle. Okay, so let's say this is our x-axis. Oh, this is bad. All right. So I think easier one would be this. So we have this nice way of cutting it. Okay. So we go from left to right and below to above. From here, let's say, draw, put a dot here, check if it's in within the circle, then again put a dot, check if it's within circle, and then put a dot, and so on. And then and if it goes out, then we go again and then start checking with other dots, and so on. So so basically this kind of counting the dots is really intensive. It's really intensive. So instead of doing it on one machine, what they have done is they have said that, okay, find out on one machine this piece, okay, and on another machine, let's find out this much and this much, and so on. Okay, this way they have divided the work. Okay, counted the dots in a distributed fashion, counted the pixels in a distributed fashion. That's all. Okay. And a lot of time when people face these kind of problems, and these kind of problems, they feel that there are many problems that cannot be converted into distributed, but after a little thought you can generally convert a problem into distributed. The way here what we did was we sliced the circle into parts so that some part of the circle dots get counted in one thread and some part get counted in another. Okay. Now, the other important part to know is when we are running the Spark on Yarn, this was easy. That there is a driver, so there is a driver and there is a Spark application. Driver is the one who launches the program, like the way the shell, the interactive shell from where we were doing the programming, and then when we executed something, right? So that was our driver application. So driver application basically is the caller, and the actual program is run on the machine nearer to the data. And that actual program is called Spark application. Okay. In our case, here, this program, gets executed nearer to the data. Okay. So a question arises that when we are running our Spark on Hadoop cluster or on top of Yarn, you remember Yarn? There were containers, there were these something called uh, there were containers, and there were mm, something called resource manager, and there was this head office, what we call that application master. Remember that? So Spark application and driver need to run on the Yarn cluster. So question arises that where would driver run? Will driver run on resource manager? Answer is no. Will it run inside container? Maybe. Or will driver run on the user's machine, whosoever is submitting the job? Okay. Good news is that you can specify that while calling PySpark or Spark Shell or any Spark Submit job. We can specify whether we would like to run our driver on the client, or do we want to run the driver inside the Hadoop itself, inside the Yarn itself. Okay. So when we want to run the driver on the same machine on which you are standing, then we say that it's master Yarn client. If you want to run inside the cluster, we call it master Yarn cluster. Okay. This is the more better way of doing things in production. This is a better way of doing things when you are doing data analysis, because you will be using most likely the interactive way. Okay. And when we are running, say, the Spark application in the client mode, this is the user who has submitted the job. It's a Spark job. And this is, remember our Node Manager 1, Node Manager 2, Node Manager 3, and Node Manager 4? There are, they run the containers, you see? They run the containers. So this driver application would basically run on the machine of the user in case we are running the Yarn client mode. And this driver application would run on one of the machines, you see? Okay. All right. Yes. All right. I think this is a little too heavy. We should first try out more Spark and come back here. What do we say? All right. I think that'll be better. But let's just don't worry. We'll come back to this slide again later. Okay. So again, a step back. So when we executed a Spark interactive shell like this one, so when we say, let me get out, I'm saying Spark shell, right? Spark shell. This will launch an interactive shell where we will type our commands, correct? And interact with the Spark or our objects. So this will launch a shell from where we will be interacting with the Spark. Let it load, right? It's trying to connect to Hadoop and trying to start it. Okay, so this is my shell. Okay, everybody okay till now? RS? Okay, so at this point, so this is the prompt. This is like somebody asking you, give me a command and I'm going to do the execute it for you. This is interactive shell. Okay, also it contains the driver as well. This is the driver as well. Okay, and when we execute something, okay, it's going to run something on the cluster. Okay, that's called Spark application. That's called, like, for example, here I'm saying load data and then give me 10 records. So it actually did something here. You see, you can see input is split. Okay, it actually did something here. It talked to Hadoop, loaded the data, and then gave you these 10 records. Okay, I said where data and so on, right? So this execution of the work happened. Yes, it's a command line interpreter. Okay, this execution happened inside the cluster. Okay, is my voice breaking for others? Okay, all right. So, okay, so I have more votes, Ravi. All right. So you might check your maybe headphone or connectivity. All right. So we got the idea about what is a driver and what is application. Yes. Now, in this example, we are saying that when we are running something on Yarn, where will driver run and where will application run? It is clear that the Spark application will run inside containers. That's clear. But question is, where will this driver run? The driver is the one which is launching the program, and the actual work is being done by Spark application. So Yarn comes up, I mean, the Spark guys who created a layer on top of Yarn, they came up with these two options. Either run the driver on the same machines from which the customer is launching the job, or run the driver on one of the node inside the cluster. Okay, so this is client mode where driver application is being run outside the yarn on the machine where it is launched. If the driver application shuts down, then if the client machine shuts down, the driver application process is killed. It does not have resilience, but it is quicker to run. So driver does not really gather the data. Driver basically launches the work to the Spark application and then does the work. Unless, very good question, Mohsin, unless we explicitly say so. For example, in our case, we said sc dot take, then driver actually, that take meant that driver wanted data back here. Driver wanted data from here to here. Okay, so this is client mode where driver is running outside the yarn. Okay, the way you run a job, the previous job that I was showing you, you can actually try that, running that. I'll show you. Okay, let's say we have this and we are running in a local mode. Okay, so we're submitting the job. So as I was telling you that you can actually submit the job like Hadoop jar. So using Spark Submit, you can submit the job. Okay, so it's basically executing that work. And if I go up, all right, it would have shown the pi value is 3 dot something. Okay, somewhere it must have done. Yeah, pi is roughly this much, 3.141588. Okay, if we increase it to say 15, it'll take more time and accuracy will be better. Okay, so you can see that. All right, good, good. So here, the way we were providing the stub driver entry point, remember? In the same way, we provide that this is the entry point. Spark Submit, this is the entry point. This is the bundle of code which contains my classes. Okay, that's what it is. So we are saying Spark Submit, this is my entry point, this is the bundle of code, and we are providing one of the we are providing this particular option saying run the master locally, meaning the driver needs to be local. Okay. All right. Good. Now the same command we could also run with saying that let this driver be run as client. Okay, by saying this. Okay. Third is the cases where we would like to run our driver application on one of the nodes. This is how it would look like. This is how it would look like. Okay. So here, in case the Spark is running in a cluster mode, meaning when we are submitting a job, it is running in a cluster mode that we can run by specifying a command line argument. So we are saying Spark run our driver application on one of the machines. inside the container or application master. Remember, application master or the container also runs inside the container, and so on. You can see that? This is essentially container, not really application master. Or you can say that application master is running it. Okay? Because application master contains the logic communicating to others, and that's why the driver application is like your app master. Okay? All right. So this is the architecture. Although it looks a little complicated, we have Node Manager 1, Node Manager 2, Node Manager 3, and Node Manager 4. And we have Container 1, Container 2, Container 3, Container 4. Now, this is our resource manager from Yarn. User is submitting the work to resource manager. Resource manager is finding a container in which to run the app master. Inside the app master, the driver application is run. Driver application talks to the resource manager and creates these Spark application again on every node. And there on Spark application node, this construct RDD is created. Okay, this RDD is basically created by virtue of this driver application. All right. I hope it is clear to everyone. I know it's a little difficult in the beginning, but as we go forward, it'll be more easy for you. You'll get familiar with the terms and it'll bring more clarity to us. Okay? Please keep asking questions. That's the only way I will learn whether you have learned or not, or and I'll learn whether I could explain or not. All right. Okay. So to run something in a cluster mode, you can simply say master and the cluster. Okay. And so this is how you can get started. All right. So once started, you can find out on which console you are logged in, and then which port is assigned to you. Like for example, for me, it was this port. You see, 4047. So it starts with 4040, then try 4041, 4042, and so on, unless it finds it empty. Okay. So instead of calling this way, you substitute this with your console name. For me, e.cloudxlab. That way you can take a look at what's going on. All right, let's move on further to, I think this is a quick example of Spark. Let me just take a look at whether we need to learn Python now. Sorry, not Spark now or later. I think we will need to learn Spark first, Scala first. Okay. All right. So that was our quick getting hands-on with Spark. Okay. We will come back to Spark again after we have finished our overview of Scala. Should we move on? Okay, I got one more, 3 votes, 4 votes. All right, wonderful. We are going to cover only basics, Sunny. We are not, our purpose is that you all should be comfortable in writing code for Spark. Okay, I'll leave most of the work to you as assignment. Okay, because finishing Scala itself would take around 14 sessions, but I would basically pick and choose what we need and what is necessary for learning. Okay. If there's something which is not sufficient at any point of time or is not enough, we might like to extend that Spark a little bit. A question from Kar, which is recommended for Spark programming, Scala or Python? Okay, so that's a tough question if you ask me. Let me answer this in a while. Okay. Okay, because yeah, I'll give you a very good. Yeah. It's a tough call, Kar. So I started training people in Spark using Python. Reason was Python was very easy to pick up. And Python is something which most of the data scientists use, right? You have scikit-learn, you have SciPy, NumPy, etc. So there are so many libraries in Python for data science, and it was easy. It was easy for all the people. So that's why I started with Python. And but there was one problem. Spark is written in Scala. Okay, so newer libraries are generally available in Scala first. Also, some of the products, you know some of the components are only available in Scala. For example, graphics. Okay, so that's the reason using okay. The last reason is to use Scala is our reasoning behind Scala is generally faster. So if you are doing something very intensive, it might pay you back if you are using Scala. Okay, great, great. Tamika is suggesting Kotlin. I'll take a look at it. Thank you. Yeah. All right. Just give me a second. Any other questions? All right. Oh, what does it mean, Kar? Where Scala chokes? Um, I mean, you mean that the places where Scala is not good? All right. So actually, a lot of syntax is more like Java. So what happens is that you develop a little fear of coding. That's the only part I did not like about Scala. Okay. And there's a ever going debate on type safe programming language and the you know dynamic typing, strict typing and dynamic typing languages like Python and Scala kind of war has been going for years. Okay. A question from Sunny: which version of JVM is required to run Scala applications? Scala can actually compile to various kinds of versions. So Scala provides you a way to compile for various JVM versions. Okay. While compiling Scala code, you can specify which JVM do you want to support. All right. Good. Great set of questions. All right. So Scala is a modern multi-paradigm programming language designed to express common programming pattern in a concise, elegant, and type-safe way. Okay, so Scala is statically typed. What does it mean? Meaning, it does not infer the data type by itself. You have to specify. Instead of saying x equals to 10, we will say int x equals 10 or where x equals 10. Though Scala tries to infer the data type as much as it can, but since Scala is designed to be statically typed, a lot of correctness, a lot of niceness comes into play. For example, when you compile Scala code, a lot of errors are caught at the compile time. So you can prove correctness before putting the code in the production. So when you compile, a lot of errors are caught, and therefore in the production, those errors may not occur. Okay. Okay. I think I missed a question. Yeah. Okay. Sure. I'll share the learning material of Scala. And Sunny's question is, a point is, it depends on someone's choice and comfort zone. Yes, that's right. And okay, where Scala is not scalable, I guess. Scala, I mean, it is not the programming language. It is mostly the infrastructure like Spark or MapReduce that's more important, which is making things scalable. Okay. Next question from Ravi is that the way I look at Scala is, since it is simply a language, scalability may not be that much relevant to Scala. Not sure. You are correct, Ravi. You're totally right. All right. Okay. So basically, the beautiful part that modern languages have done, be it JavaScript, be it Python, be it Scala, most of these modern programming languages, they have become general purpose. They have become general purpose. For example, JavaScript is also used on the server side in Node.js applications. Okay. Similarly, Python is used in many contexts. Similarly, Python is being used with Spark and so on. So the framework, so for example, there's a new framework from Google called TensorFlow. Exactly like Spark, it also runs from Python, it runs from R, it runs from Scala, and so on. Okay. So programming languages have just stayed like a construct, a language of communication. The way we have language of communication, and then there are businesses, then there are the art houses and so on where we communicate, though vocabulary might be different, but it's the same language. Okay. Yes. All right. So Scala is statically typed, so you can compile, and because of being statically typed, meaning you have to define most of the types upfront. For example, while we were defining a function in Python, right? We were defining our function in Python earlier. Here you see, we did not have to define the data type of what we return and what we expect in this function called myUpper. So in this function, we did not define the data types of input and output. But when we are defining a function using Scala, we would be defining the input and output arguments. And most of the statically typed languages are far more performant, and it's a proven thing. It's mathematical proven part. They're statically typed because they don't have to they can allocate exactly same amount of memory and so on. They are generally far more faster. Okay. So the one thing Scala has tried to do is they have tried to make the the syntax to be very similar to Python. They have tried to simplify Java syntax to very similar other data-centric language. So they have actually made Java usable in case of data churning. Okay, it is stable as well as innovative. It is used now in enterprises, financial sectors, retail, gaming, manufacturing, and more. And by the way, as a quick fact, if you're looking for a change, Scala is probably the hottest language in the market. Okay, you should take a look at. All right, and yeah, I took a look at it in couple of portals. You can take a look there. Yeah, that's right, Ravi. All right. Now, a little history about Scala. It started with Martin Odersky. He was the founder of Scala. He tried to make Java better via something called generics. You remember those angle brackets we defined in the classes, right? Where we defined the data types, input data type, output data type, and all of that. Those between angle brackets while defining classes at the top after our stub mapper. Remember? Stub mapper, extend mapper, and then angle brackets. That is generics. Okay, that's a Java's feature called generics. So Martin basically implemented generics in Java compiler. Okay, and that's what made a way for you know that's what started him on Java, and he realized that he can make Java, he can create a better Java. Okay, so that's where he created the first experimental release. The clever thing what Scala has done is when you compile Scala's code, it becomes Java's jar files. You remember when we compiled our Eclipse code in Eclipse or GitHub, right? It generated jar files containing classes, right? Similarly, when we compile Scala code, it actually generates Java classes, right? Those classes can be run on Java virtual machines. Java classes in terms of bytecode, dot class files, not dot Java files. Okay, so when Scala code is compiled, it generates Java bytecode, which can be run on any JVM. Those who are not aware about Java, in Java, the .java program, whatever programs you write, they get compiled to something called dot classes containing bytecodes. Bytecode is run on top of JVM. So to run your Java programs, you always need JVM installed on the target machine. Okay? So yes, so he realized that getting the adoption of JVM, imagine that there are millions of servers around the world. All of those servers have JVM, but not necessarily Scala on them, right? So getting something adopted on the server side is harder, right? And that's where the death of most of the programming languages occur. If there is a need of some installation to be done on the servers. I remember my days when I was at InMobi. We needed a particular newer version of a library on our cluster, and they blatantly turned me down, saying that no, we cannot do that. It's your problem. You should bundle your code in something that it installed automatically or something like that. We will not install or upgrade our cluster for your need. Similarly, had Scala come with its own virtual machine, that virtual machine would be installed. Virtual machine, not like your the virtual machine for Hadoop. Virtual machine is like an interpreter that runs and executes bytecodes. Okay, All right. So they basically created a newer language. He basically realized that he can make better Java, and that's where he created Scala. All right. And by 2011, Scala started getting adoption in the industry. Yes, Scala is that. Actually, Scala was done in 2005, 2003 actually. Okay, it was first released in 2003. It's actually newer as compared to Python and the other languages. All right. Now, the question which Sunny has asked is hard. Why are they not creating their own compiler interpreter? Why are they not creating their own They have created their own compiler, but not interpreter. Interpreter is JVM. JVM runs bytecode on each machine. All right. So Scala source code gets compiled into Java bytecode. Java bytecodes run on JVM to give you the actual result. The resulting bytecode runs on JVM. Java libraries may be directly in Scala code and vice versa. Okay. So Java libraries, you can use Java libraries in your code. Now, this is another advantage of Scala. So Scala not only compiled to run on any JVM anywhere installed, but they also made it possible that if you don't have something in Scala, start using from Java libraries itself. For example, let's say somebody has created a library for mathematical or graphical operations. You can use those libraries inside your Scala code. Okay, so that was a clever move, and probably there are not millions, there are hundreds of languages around the world. Okay, getting adoption is hard. So these are the reasons. One, Scala being more performant. Scala, the output of Scala can run on JVM everywhere where Java can run. Scala, your program can run. Your Scala program can run anywhere Java can run. Okay, therefore that's how Scala got adopted. Okay, so you can log in into CloudX Lab console, type Scala on the terminal, and try the following command. So all of you, feel free to type Scala on the console. I'm going to go here and say Scala. Okay, this will start Scala. Is everybody there? And we are going to write very hard program, which is 2 plus 2. Okay, so it's difficult for us to compute 2 plus 2. So we are going to use Scala for that. All right, so everybody there? Anybody stuck? Does it support javascript.js file? I doubt. I don't think it does. But there will be JavaScript compilers in Scala, definitely. So what you can do is, if you really want to compile or run JavaScript code from within Scala, you can import Rhino. There's a library called Rhino. Okay, so not this one, this one. Okay, so there is a jar which can run any JavaScript program. Make sense, Marcin? Is that what you were looking for? Okay. All right. Is anybody stuck? Need help? I don't see 27 yes, although there are 27 people in the session. Yes. So in open source world, people tend to even create tend to create and name their products as on elephants on animals. So for example, the Pearl's book is called Camel Book. Okay, and yeah, there are almost a good tendency, not since Hadoop, but long back, people have been naming things on animals. Mahat, yes, Mahat is a person who sits on elephant and controls them. And Ambari, for example, is that cover around the Mahat. Well, I think not that the the umbrella and the whole setup on top of elephant, right? That's called Ambari. Yes, that's a better reason, Kar. There's no copyright and animals will not take you to the court, right? Right. Good, good. So are you able to run it? And yeah, or you can simply try running a simple function called print. This is scalar. Okay, let me try. So single quote A means the ASCII value of A, okay, which is 97, right? So 97 into 20 is that. Sudhakar. All right. So this is how we can get started with Scala. Okay, so yes, done. All right. So next thing we are going to do is create a text file, simple text file, right? By nano hello world Scala. Okay. And then put this code inside that file. Okay. And then run it like this. Let me try. Exit Scala prompt. So one way of running your program was from the interactive shell. Like our usual program, we can do the same thing with Scala as well. So here I'm creating a very simple program like println hello world. Okay. Now I can say Scala hello world. You can see, right? All right. So that was our first program on using Scala. So we edited a file using Nano. Basically, Nano is a text editor which helps us launch this editor, the editor that will edit this file called hello world.scala. It'll also create a new file. And then we put println bracket double quotes hello comma world double quote closed and then bracket closed. Okay. And then we say Control X and save it. Yes. And then we run Scala hello world.java. Okay. Of course, Nano should be executed from this dollar prompt, not from Scala prompt. Yes. Nano. When you typed nano, I think you typed on scalar here prompt, or you have to exit from there. You can press Control D, Control and D to exit from scalar. Only once, not twice. Just press once Control D here on scalar prompt, and then you will come to dollar, and then you type nano hello world dot scalar. All right. So we'll continue our discussion on scalar tomorrow. Okay. We will go through multiple constructs, and then we will start working with Spark. Okay. I'll send you the videos related to Scoop, Flume, and Uzi. Please go through those videos. All right. And we can have discussion next Saturday on those 3 videos. All right. Is everybody okay with this? Tomorrow is Scala. We should finish Scala in like 1 hour, and then we will continue Spark. All right. See you tomorrow. I look forward to see you with little more hands-on on Scala. All right, Tanika and everyone. All right. Thank you, everyone. I look forward to see you tomorrow. Bye-bye. All right. Great. Okay, Ravi. Bye-bye. Have a good day. Bye all. Bye, Jankun, Krishna, Narendra, Nitesh, Ravi, Sudhakar, Shruti, Sunesh, Srini, RS, Tamika, Tegu, Srini, Sunny. Bye-bye.